I would say it's a bit of both. I
Mhm.
think for my case, I mean, it's kind of like a big thing, right? Like civil engineering is very broad, and I'm sure most majors are like that. I would think it's very rare
Mhm.
that you would ever find a job that's like exactly about what you learned at school. But what I would say is you kind of learn a job and you learn certain skills, but there's little pockets of things from your education that keep coming up. For example, I didn't know how to be an engineer, but there's things that I learned at school that I knew how to do, and those served me well. I also think that, especially for engineering, maybe more than other majors, you really learn how to think, and how
Mhm.
to problem solve and how to really get deep into the core of an issue, or how to work, in a group setting about
Mhm.
an issue or a problem, or something, or even like we had like project type classes. So all those experiences will help you when you start working. I would think, I would say to most people, you should not expect what you learned at school to come up
Mhm.
every day on your job. It's not like you're not going to show up and they're going to give you, statics homework and be like, okay, solve this now. It's more like you learn how to think, you learn all these things that maybe while you're at school don't all make sense together, but then you show up at work and on a Tuesday, your very weird knowledge about steel structures will come into play.
Mhm.
So, you know eh, you're not going to use every single thing you've ever learned at school, but you are going to use how you are thinking, what you thought, everything you learned along the way, all the cultural things you learned along the way, and especially the what is that, what is this, like, what's a trust, what stuff like that. Yes, you'll use. Um, in my case, it wasn't super like calc focused, so I didn't end up doing like a bunch of math and physics, but it definitely helps. And when I'm talking to a structural engineer on the phone, which would occur almost every single day, I know what I'm talking about because I did it at school. You know what I mean? It's like, don't expect work to be like school,
Mhm.
but your knowledge will serve you well. Like along the way, it'll come up here and there.
My role here is, very analytical, and one of the platforms I'm developing, obviously, it's a technology platform, so you need to understand, the different, applications that you're going to be building this platform on top of. And I learned the base of that in USC within my computer science curriculum. Learning how to code, learning how to do different type of like data analytics, data engineering, object-oriented programming. It all came into play. I think a little more, out of college in my consulting role, where I was doing like hardcore data analytics and hardcore like technology implementations for clients. Now I'm more of a managerial role, so I'm not actually like day-to-day coding, but it definitely, helped me develop my understanding of that kind of work. And so it allows me to manage the people that I do manage in doing some of that more data heavy, in the weeds type of work in order to actually build what you're trying to build.
Yeah, so I think that doing an engineering undergrad is really helpful in a lot of ways. I think that I learned how to work on teams really well as a Viterbi undergrad. And I think that that comes up all the time in medicine because medicine really is run in teams. The way that hospitals work, we have so many different people from different disciplines that come together to support each patient. And so it's really good to have a lot of skills in communicating with people from different disciplines and kind of having a very team oriented mindset. I think that my specific engineering knowledge also is useful in certain contexts. So, for example, for my first few years here at NYU, I worked a lot with our Tech for Health Institute, which is a new institute that has a lot of engineers, mostly different kinds of hardware engineers that are essentially sourcing problems from doctors in the medical center and working together as teams to prototype solutions for those problems. And I found that as part of one of these teams, I was able to contribute both from an engineering perspective and thinking about, for example, the types of materials that would be appropriate for our device, but also from a clinical perspective, increasingly thinking about things that needed to be considered if we were going to implant this into a patient, and thinking about how the current standard of care is currently conducted and kind of how ours would be comparable and kind of what parameters would be most important for it to be clinically useful.